Alright, so we're going to talk about the periodic table and specifically what you need to know in order to do well on your periodic table essential skill. You have quite a few things to know about the periodic table. The first is all of the different groups and what they're actually called. Now, you don't need to know every single group on the periodic table, but you do need to know the major ones. So I'm going to go through really quickly. Group 1, if you ignore hydrogen on the first group, those are called your alkali metals. Group 2 is your alkali earth metals. If you skip over, you go to the big section in the middle. These are your transition metals. These are more common metals. They're harder, they're more conductive. The first two groups are a little bit more reactive. The first one is definitely the most reactive. Those are the majority of all of your metals on the periodic table. The only other metals to kind of highlight would be down here. These are your rare earth metals, so these are the ones that are more commonly either man-made or found synthesized in the lab instead of in earth, which is why they're called rarely earth or rarely found on earth. The other things that I want you to know, the halogens are group 17. So these are over here. Those are the most active non-metals on the periodic table. And then group 18, these are the noble gases. So those are the ones that won't react readily with other things on the periodic table because they already have stable valence electron shells, so they don't need any more electrons. If I get rid of that, we can look at the clean periodic table again. In general, the periodic table is also divided up into 3 categories. I'm not going to use the term groups, but overall categories. Anything from this zigzag line and to the left, these are all metals. I remember that if you find common metals, silver, iron, titanium, platinum, gold, all of those are on the left-hand side. There is one exception, and that is hydrogen. That is a non-metal. The other non-metals are to the right of that zigzag stair-step line. The last category, so you have the metals on the left, non-metals on the right. The last category is going to be the metalloids. There are more than 7. There are 8 metalloids. They're the ones that I just highlighted in yellow there. Those are the ones that are on the zigzag line. They share properties that are both metallic and non-metallic. So some metallic properties of all of these elements over here, they would be things that are shiny, they're conductive, they're malleable, they can be pounded into thin sheets, they're ductile, they can be drawn into thin wires. Non-metallic properties of those things that are over here are going to be the exact opposite of metals. So they would be maybe dull, they're not very shiny, they're brittle, they'll break instead of being able to be reformed. They're also not really conductive. Metalloids, like I said before, are things that they're elements that have both properties of metals and non-metals. So they kind of are the happy medium, I guess, between those. So if I again start with a clean periodic table, we know that the periodic table has both rows and columns. Columns are more commonly called groups, so that's up and down going across, numbers 1 through 18. All of these have various properties and patterns amongst them. They all have similar properties if they're of the elements in the same groups. The most important that you need to know is the valence electrons. So everything in group 1 has 1 valence electron. Everything in group 15 has 5 valence electrons. You're just looking at the last digit of the group number. Everything in group 18 has 8 valence electrons, with the exception of helium because it only has 2. So valence electrons are extremely important for you to know. If you look at your periods I told you guys this in lecture, but if you're going across the periodic table in rows, these are called periods. I remember that because if I write a sentence in English, I'm writing my sentence, and at the end of my sentence, I have a period. I write my sentence left to right, periods at the end. So that's how I remember that one. But everything in the same period has the same number of energy levels, meaning everything in period 2, if I draw my, let's get a different pen. If I draw my nucleus, I have 1 and I have a second energy level for my electrons to sit on. So everything in the same period, or in a common period, has the same energy levels. Along with that, you can look at atomic size or the atomic radius of an atom. If I'm looking at hydrogen, which is in the upper left-hand corner up here, that only has 1 energy level. So if I compare that with francium down here on the bottom, that has 7 energy levels, being in period 7. So francium has to be a lot bigger. It's going to be a bigger atom than hydrogen because it has more energy levels. So atomic radius actually increases as you go down a group. The opposite is true if you're going across a period. Atomic radius is actually decreasing because you have more protons. They're all in the same energy level. They'd all be in the 4th energy level for this row. But going across the period, you have more protons over here in krypton than you do on potassium on this side. So with that being said, krypton has more protons, it has more positive charge in the center, so it actually pulls those electrons in tighter, meaning it's a smaller atom. If we're continuing to look at trends really quickly, reactivity you guys looked at with your reactivity lab. Again, if you're comparing that or looking at that with the zigzag line dividing your metals and nonmetals, as you move further and further away from that zigzag line, you are more and more reactive for your metals and your nonmetals. But you have to be careful because with the nonmetals, you're going the opposite direction, obviously, but you also want to omit or get rid of your nonmetals, or your noble gases for this trend, because those we already know are not reactive. They're not going to react with other things readily because they're already stable. So with that being said, your most reactive nonmetal is fluorine, and your most reactive metal is francium. The last trend that I want to mention is ionization energy. This is for when you're comparing or when you're thinking about the amount of energy required to remove an electron from an atom. So if I think about things that are at the top in period 2, those only have 2 energy levels, so they are relatively small in size, meaning that those protons that I just drew are going to attract the electrons a little bit more than things that are going to be down here, let's say francium or even bismuth, because they have more energy levels, so those electrons are going to be farther away from the nucleus, meaning they're easier to take away. So overall trend for ionization energy, as you go down a group, it decreases because the energy required to take away an electron is less. The opposite is true if you're going across a period. It's harder to take away an electron over here than it is over here. Again, with the size, but also if you think about your valence electrons, this column is already stable. It doesn't want to remove an electron. It's happy with its number of electrons. Whereas this column is not happy with its electrons. So the valence electrons in the noble gases over here on the right is stable. Valence electrons with your alkali metals is not stable. I do believe that is everything that you need to know in order to do well on your periodic table essential skill. Good luck, guys.